Hi, welcome to clickmyproject.com. This video will lead us to enhancing the genetic-based scheduling in computational grids by a structured hierarchical population. In this process, we are going to see how client jobs are allocated to the system available in the grid environment in cheapest cost. In grid system, independent job scheduling is manifold beneficial account of happening of scheduling. In grid system, independent users compiled jobs or applications to grid resources. The scheduler desired to estimate adequate and excellent formulation of jobs to the available resources in grid environment. Hierarchic genetic strategy is one of such meta-heuristic approach which is different from genetic algorithm by its simultaneous search of the solution space. The HGS scheduling method is improved in order to minimize the makespan and flow time, which outperforms the GE-based schedulers. But the computational cost to complete the process is too high. For this purpose, we propose bacterial foraging optimization algorithm, which reduces the cost to complete the process submitted by the client. By using this algorithm, the scheduler will schedule the job to one of the available resources in which the job can be completed with minimal cost. Now we are going to see the process flow. First, we create a grid environment with 4 different sizes of resources. Then we submit the resource details to grid information service provider who schedules the client job to the resources available in the grid environment. Then we initialize the broker, user and a scheduler. After initializing, we connect scheduler with the available brokers. Then we create tasks based on the style selected by the user. Then we submit the user task to the resource broker for processing. Then the resource broker submitting job to simulator for simulation. Then the simulator scheduling the problem instance. After simulating the problem instance, the simulator sending jobs to the scheduler. The scheduler schedules the job based on HGS algorithm. Then he calculates the population for n jobs. After calculating the population, he submits the job on machine I, which has minimum ETC, repeating the above process until all jobs submitted to the available resources. After processing the job, the scheduler schedules the job based on BFO algorithm. Then we calculate the population for n jobs. Then we submit the client job on machine I, which has minimum ECC, which means expected cost computation. Then we repeat the above process until all jobs submitted to the available resources. After submitting all jobs, we have to calculate the cost for processing client job for both HGS and BFO. Then we evaluate the performance based on the cost. Now we are going to see the demo of the whole process. To start the process, first run environment creation.java. Here we can select the type of the environment. Here I am selecting the static environment. Then we have to select the size of the environment. There are 4 possible sizes: small, medium, large and very large. Here I am selecting the size small. The host will be created based on the size we have selected. Then we have to click the create button to create the environment. Then we are going to initialize the brokers and clients. First, by clicking the create button, we are going to create the broker and clients. Then we are going to view the created brokers. The broker and client will be created based on the size we have selected. Then we are going to create the task. Here I am creating 512 tasks. Then I am updating the task in the database. Then we are going to view the task. Then we have to submit the task details to the broker. First I am submitting the task to the broker, then to the scheduler. Now we are going to compute the ETC matrix. That means expected time to compute the process matrix. First, we have to calculate the workload vector of all the tasks submitted to the scheduler. Then we have to calculate the computational capacity of all the machines available in the grid resources. Then we have to compute ETC matrix based on the task and computational capacity of machine I, which means all the jobs are submitted to all the machines to deduct the time for completing that job. Then we are going to see the GA settings for large static and dynamic benchmarks based on the elastic generational and in steady state. Then we are going to see the settings for SGS based on the elastic generational and in steady state. Then we are going to schedule the jobs based on the GA. Then we are going to process the job submitted to the users. Here I am processing the job which is submitted to the resources. Then we are going to schedule the job based on SGS scheduling. Now we are going to calculate the computational cost for processing the client job based on SGS. Then we are going to view the cost. After that we are going to calculate cost based on the bacterial forging scheduling algorithm. Here I am calculating the cost, then scheduling the jobs to the machine I which can process the client jobs with lower cost. Then we are going to receive the processed job from the resources. After that we are going to evaluate the performance of our proposed algorithm based on the cost. Here I am evaluating the cost and we are going to view the graph of the performance. The graph shows that bacterial forging scheduling computes lesser cost than the SGS scheduling. In this process, we can see that the client requests to complete their jobs to the grid environment. The grid environment get the jobs from the client and submit to the scheduler for processing. The scheduler schedules the job based on the cost and they collect the cost from the client for processing their job. The grid environment provides service to the client to complete their jobs in short time and in lower cost. Thanks for watching us.